Hi everyone. In this video, I want to talk about the concept of Z tables and percentiles. In last video, we talked about Michelle's score is 0.7288 standard deviation above the national mean. But we did not talk about her percentiles, which means that if we look at the standardized normal distribution, 0 for the mean, and then Michelle's score is 0.7288 standard deviation above the mean. And when we talk about percentile, we want to look at how many percent Michelle's score is higher than. How many percent of the students, then how many percent of students, which means that we'll be looking at this shade area here that's below 0.7288 standard deviation above the mean, right? So we'll be looking at this range here. Since the information we have on hand is for a standardized normal distribution, we can easily use the Z table to get the information we want. And if we look at the Z tables here, right, this are for the positive Z scores, right? So these values are positive. And the one here are for the negative Z scores, okay? Now let's see how we can use the Z table to get the percentage we want, or get the area, the shade area here. So we have our Z score to be 0.7288. Now, since we have positive Z score, we're going to look at this table here. First, we're going to look for 0.7. So 0.7 is here. And then we're going to look for 288 here, right? So what we see is we have 0.7.2 and 0.7.3, right? So our Z score is in between these two values, but since it's closer to 0.3, I will just go ahead and pick out this value here, okay? So with the Z table, we got the value to be 0.7673. What it means is that Michelle's score is above 76.73% of the national students. Okay, right? Remember, this normal distribution represents the distribution of student scores. So we have the Z score to be 0.7288, means that the shade area here is 0.7673, which means that 76.73% of the students, their scores are lower than Michelle's score, okay? And this is how you get the percentage from the Z table or from the Z score, okay? Now let's talk about how you will get the percentile using the information we have. So now let's talk about percentile. So the first step is what we did in the previous video. We want to convert the original number into Z score. So that's the first step. And then we're going to use the Z score and the help of Z table. So use Z table. We're going to find the value. Using the Z table. And then we want to convert the value into percentage. To convert, oh yes, we're back. We're going to convert into percentage, right? So we're going to get the value, and then we want to convert the value into percentage. Finally, we want to, or we need to, round down the value. Okay, what it means? Round down means that in the Michelle's case, we have 73.73%. And since we want the percentile, we don't want the numbers after the decimal. But the way we do this is always going to round down, which means that this will give us 76% or 76th percentile. Okay, remember we're going to round it down, and we're going to get rid of all the numbers after the decimal. Okay, perfect. And this is how you get from the raw number, or the original number, into a percentile. Now let's do the reverse, or the opposite. Now we want to talk about using percentile, and we want to get the original numbers, original scores, right, or numbers. Okay, let's say Michael. So Michael's SAT score is in the 35th percentile. So his score is in the 35th percentile. So in the 35th percentile, since when we get the percentile, we round down the value. So this is possible to be in between 35% and 36%, right? So we don't know. Okay, so 35% equals 0.35, and then 0.36. Okay, so now we're doing opposite, or we're doing the reverse. The next step we have to do here is, since we got the percentage, we got the value, now we want to use the Z table to get the Z score, right? So the next step is to get Z score. Okay, 0.35 and 0.36. Now if we go to the Z score table, now we're looking at the middle, right? So we're looking at the middle. So instead of looking at these two sets of values, we'll be looking at the middle for the probability. Okay, so 0.35, we're likely to be looking at the negative table. Yes, we're looking at the negative table. And then 0.35, it's about here, 0.35197, and then for 0.36, it's closer to this value here, 0.35942. So in other words, the Z score we'll be looking at should be negative 0.36 and negative 0.38. Okay, so we'll be looking at these numbers here, these two numbers here. Okay, so for the 0.35 from the Z table, we have the Z score to be about negative 0.38. For the 0.36, the Z score, it's about negative 0.36. Okay, so we have these two Z scores. So we know the Z score should be in between negative 0.36, and negative 0.38. So the z-score should be greater than minus 0.38 and less than negative 0.36. Okay, so we have the range for the z-score. Now we're ready to get back to the original score that we have. Okay, remember the formula we used to get the z-score is z equals to x, right? The score or the round number or the original number minus the mean and then divided by the standard deviation here. And then in our previous video, we talked about the national mean for the SAT is equals to 514, and the standard deviation is 118. Okay, now let's rewrite this formula here. So this formula, z times q equals to x minus mu. So mu, or no, x is equals to z-score times the standard deviation plus the mean. Okay, and we're going to use this formula here. So we know Michael's original score should be greater than negative 0.38 times 118 plus 514, and should be less than negative 0.36 times 118 plus 514. So therefore, the original score should be greater than or equals to, let's say equals to 496.16 and less than 472.7. Okay, so now we get the range of Michael's original score. Okay, so in this video we talk about how we can use the z-table to get the percentage and percentile from the z-score, and also we learn how to use the percentile to get the original score. Thank you for watching. I'll see you in next video.